Hello, this is Mr. Ferris, and I'm going to walk you through Pre-Cal Lesson 8.1, which is the first lesson in the next chapter that applies trigonometry to right triangles. So this may actually be more of a review of some of your geometry than anything else. So if you downloaded the lesson from Canvas, it should be this page here, and the warm-up is simply to use the Pythagorean theorem to solve for x. So I would ask you at this point to pause the video, calculate all three, and then when you play again, I will have the answers. All right, if you paused and calculated x in all three cases, the first x should be 8, the second x should be 13, and you notice that both of these came out to be whole numbers. And it might remind you that there are some whole number triples that we call Pythagorean triples that sometimes you can memorize to make your calculations quicker. So 8, 15, 17 is a Pythagorean triple. 5, 12, 13 is a Pythagorean triple. And of course, multiples of those would also be Pythagorean triples. The third one, however, will not come out to be a whole number. If you do it correctly, x should be the square root of 74, which is approximately 0.6023. That would be the decimal version of that answer. So hopefully that is familiar to you, and that's kind of the foundation of this next section. Now we're going to apply trigonometry functions to right triangles. You might remember another little acronym, a mnemonic, to help you remember that sine, cosine, and tangent are simply ratios of sides in a right triangle. So for instance, in this particular problem, sine is the opposite over hypotenuse. And so going from angle theta, the opposite side is 45. The hypotenuse is 53. So the sine would be 45 out of 53, which is approximately 0.8491. Cosine, by definition, AH, is adjacent leg over hypotenuse, which would be 28 over 53. So if you take 28 divided by 53, that's approximately 0.5283. And if you calculate tangent using the acronym, tangent is opposite leg over adjacent leg. Therefore, that would be 45 over 28, which is approximately actually it's not 0 point, it's 1.6071. So if you're given the sides of a right triangle, then you can calculate sine, cosine, and tangent just by using the ratios, and then you can convert that to a decimal. So just a reminder of what SOHCAHTOA means. Sine stands for opposite leg. It's probably a good idea to put the word leg in there just to remind you that it's the non-hypotenuse sides, the two smaller sides that are opposite and adjacent. Divided by the hypotenuse, that's the sine ratio. The cosine ratio would be adjacent leg divided by hypotenuse. And the tangent is the opposite leg divided by the adjacent leg. And again, the key thing is these are only for right triangles. These ratios work for right triangles only. If you do not have a right triangle, then you have to use more complicated formulas, which we will learn eventually. All right, so then another thing we just have to remember, we did this before, but with triangles, of course, we do not use radians. Radians is only for circles. So for right triangles, we want to make sure our mode is on degrees for solving these always. And so if you take out your graphing calculator, please pause the video and calculate these three trig calculations. If you calculated them correctly, you should get 0.5878, 0.3090, and 0.2126. Those would be the decimal versions that you can get from your calculator. Again, as long as you're in degree mode, that should work. All right, moving right ahead. We can now use inverse functions as well, just like we did in the previous chapter. This time, we would use inverse functions to find an angle of a right triangle using 2 of the 3 sides of a right triangle. So for instance, if you were given the 2 legs, then we could use the trig ratio that involves the 2 legs, and that would be tangent. We know that tangent is opposite over adjacent leg. So in this right triangle, the tangent of theta would be 7 over 12. And if that's true, then the arctangent of 7/12 should give us the angle. This is using the inverse tangent to solve that equation, so it's kind of working backwards. So again, if you type that into your graphing calculator using the mode degrees, of course, you should get approximately 30.26 degrees. So just over 30 degrees. And you might even remember that some of the ratios that we learned in unit circles are still going to be valid here. So anytime you would come out with angles close to the ones on a unit circle, why then you should expect to get answers close even in a triangle. So you'll see some crossover there. One of the things that's cool about triangle trig is it does apply to some story problems, some context problems. As long as you can draw or sketch a right triangle, then trigonometry will be applied and applicable. So in this case, a hiker is heading across a plain in a direction that she thinks is due east, but her compass is off. So she's actually traveling this direction. She thinks she's going due east, but she's actually going a little bit northeast. And so she hits a road, and she realizes she has hiked for 12 miles, but it's been kind of the hypotenuse, essentially, of what she should have done. If she had walked straight east, why, she would only be 11 miles. So basically, you can sketch a right triangle that has 11 and 12 for 2 of the sides. And if the question is to find theta, we just have to use the correct trig function. So the first step would be to look at this and see, okay, theta is down here in the bottom left. What are the 2 sides that we have been given? Turns out we've been given the adjacent leg and we've been given the hypotenuse. And so if you think about adjacent leg and hypotenuse, that is what cosine is. So the cosine of theta, which is adjacent leg over hypotenuse, would be 11 over 12 in this story. So if the cosine of theta is 11/12, we can work that backwards by taking the inverse cosine of 11/12, and that should get us an approximate angle measurement. So again, this is going to be calculator based. If you type that into your graphing calculator, you should get roughly 23.56 degrees if you go out a couple decimal places of accuracy. So there will be a lot of story problems where you set up right triangles. A common one would be, if you're standing outside on flat ground and the sun is shining and you see your shadow, you could measure the length of your shadow. And of course, you know the height of yourself. And so if you draw a picture of yourself standing up, the shadow would be the horizontal leg and you would be the vertical leg, and you could figure out the angle of the sun. And that's something that is commonly done. And as long as you can create a sketch and create a right triangle, you can usually set that up. All right, finally, just to end on, this is a pretty short and sweet lesson, but special right triangles we talked about a little bit when we put triangles in unit circles. If you cut a square in half, or if you cut an equilateral triangle in half, you will get what we call special right triangles. And I've just gone ahead and solved those because I think we've done that before. But if you have a half of a square, we're going to focus our attention on this being a 45, 45, 90 right triangle. And if you just make the sides 1, then you've got these ratios of the legs both being 1 and the hypotenuse being radical 2. Similarly, if you cut an equilateral triangle in half, you get a 30, 60, 90 right triangle, where the 2 legs are a half and radical 3 over 2, and then the hypotenuse is 1. So there are some ratios going on that make this quite nice, and maybe even have some shortcuts. You could even memorize some of these to make things go faster. I'm going to let you finish this off based on those exact values on these two special right triangles. I'd like you to fill out this table that gives you the sine, cosine, and tangent of some special angles like 0, 30, 45, 60, and 90. What's going to be interesting, though, 0, of course, cannot be an angle in a triangle. And 90 is not one of the angles we usually use for trig. We use the acute angles, not the right angle. And so those are going to have to be done a little more cleverly. And honestly, you could actually go back to a unit circle, because a unit circle will also give you those correctly. So I'll let you finish that off, and I think you've got the foundation for your lesson. What is required at this point then would be to do your practice, your homework. There's a lot of good problems to reinforce how to calculate angles and sides in a triangle. And then when that's all finished, there will be a quiz coming for credit. So as always, let me know if you have questions along the way, and I will see you soon in class.